Here we go. Maximum number of events that can be attended. You're given an array of events where events of I is start and end tuple 2 array or 1D array, 2 elements. I guess it's inclusive as well. Every event I starts at start day and ends at end day. You can attend an event I any day D where start day, where D is between the start days inclusive. You can only attend one event at time, anytime D. Okay. So here events days are starting index or one index kind of. Oh, there's no days. Okay, so events 1, 2, 2, 3, 3, 4. You can attend all 3 events. I see. And then events 1, 2, 1, 2, 3, 3, 4, 1, 2. I think you can attend all 4 events. So definitely 4 for the last one since it's the only day that or 4 for this third one, and then 3, and then either 2 or 1 for the first and last. Okay. Events length is 10 to the 5th, like 10,000. Suggest we shouldn't be doing 10 n squared algorithms because that's going to be too long. Each length has length 2, and start and end date are between 1 and 10,000. No, 10 to the 5th is 100,000. 100,000. Alright, so we're returning the maximum number of times that's meaning. Okay, so I think this is probably going to be sorting. It makes the most sense to me that you'd want to sort this. So if you do sort it, then you know what the starting date is. Okay, so let's see. If this becomes sorted, it becomes 1, 2, 1, 2, 2, 3, 3, 4. And I guess the question is, after you sort it, how do you determine like what day to use? Interesting. Interesting. So you can have maybe a day variable. You have a day variable. Okay, so let's consider the last one here. So this is your events array, and if it's sorted, then something like this. I think the only thing you have to be careful is the fact that it sorts based on the first index, and then tiebreakers is it will have the second index. And the bigger second index will cause the tuple to, so like for instance, it could be something like this. Something like that. 1, 2, 1, 10, 3, 4, 2, 3, 4. Sorting Python is always smallest to largest. So the smallest second index if there's a tie in the first index. So how do you know? So you have a day variable, and the day variable is if it was smaller than the lowest, if the day variable is smaller than the lowest day of the sort, the day variable is lower than the smallest, than the start date of the current event, then you want to move the day variable to be the start date of the current event. So like it's day is, let's say, 0, then it becomes 1. Now, and you don't, in that case, I think it's always safe to, it should always be safe to take, so if you have that event that is the smallest that a day could be, then it's always fine to assign that event to that day, because any later date is going to be either assigned to a different day, because like that's optimal. Like if you have a bunch of 1-2s, it's fine to assign the first 1-2 to the first day 1. If it's a 1-3, there's a tie, then the 1-3 is like strictly superior in terms of days that you can assign it to. So anyway, so it's always, so I would say this greedy approach of assigning events to earliest day they can be assigned is okay. If that event is the first time the start date occurs, I think. Is that right? I think that's right. Yeah, if you move the day to be this current day, if the day is prior, if the, let's say it's day like -10, right? If the day is -10 and you move it to day 1, it's always fine to assign that event to this day 1, because either it's a unique day where there's no other things that could be done on that day, like there's no other event that has 1 as a possibility. So whether you sign it now or you sign it later, it's going to be equivalent in terms of like you getting a good event for that day. If it was the only day that had 1, if there's another event that had that day 1 possibility, and that event being later on means that it's strictly superior in terms of being able to sign it later on, because the tiebreaker is going to be has a longer end date. So that greedy approach is fine. What's not fine is if it was like, if you're moving on to day 2, right? If it's now day 2, day 2 has the possibility of 1-10 and 2-3 really. So the start date is already passed, and the current date is, yeah, start date's already passed, then what? Like what if it was like 1-10, 100, 2-3? Technically, what you'd want here is to assign maybe 2-3 to it. Okay, let's be more clear. Let's say it's 2-2. You really want to assign the 2-2 to this one because that's the only day that this event occurs. But you're currently looking at this unassigned event. You're currently looking at this unassigned event. What if you sort it twice? One for start date, one for end date. We really don't want to. So if you're at this index, can you just say, can you just move past this and go to the next event until you see something that has an end date that is like at this day? I think that doesn't make sense. Because you could go all the way to the end. Okay, so let's say we have a reverse, or let's say we have another array that's sorted based on the end date. So if you sort it based on end date, then it'd be something like this. And then you can pop that off. Probably some like stupidly simple solution to this that I'm missing, or that I'll look back and maybe figure out, but in the moment I don't know. I mean, if it's an event that has a single day, I could possibly create some different counting for that. Then that doesn't really. Then 2 days is pretty similar, but it's not going to use the same accounting system. So 1, 2, 2, 2. So I say that the first event, this greedy approach is fine if you can move this current date to the start date. Not fine if you're not moving the current date. Can you do a stack? Can you do a stack? So you have, so the current date's 2, and you see the end date is 10, then you push 10 onto the stack, and then you push 100 onto the stack, and then you push, what if you push other bigger numbers? What exactly are you going to stop you from pushing a smaller number? Yes. Because it could be a small number. You push a smaller start date. If you ever push a smaller start date, then maybe that's a smaller start date than anything on the stack. Doesn't seem like it'd be. So what if it was like, what if it was something like, 1, 2, 1, 10. Let's give a 1, 100. Let's say it's 3, 6, 4, 4, 4, 5, and maybe a 5, 5. No. 3, 6, 4, 4, 4, 5, and 4, 6. Alright, so 1, 2 should be assigned to 1. That's the only day that has it. Has a 1, or yeah, it should be assigned to 1. 2, so if I look at 2, 2 can be assigned to this one, can't be assigned to this one at all, so I should be able to remove this one, assign this one 2. So if the current day is before the start date of a later event, I think maybe you should be removing based on the end date. So let's say there's a 2, 2 here. So all these things are assignable. If there's multiple things that are assignable to the current day, then you want the tiebreaker to remove the event that has the earliest end date. The earliest end date. If there's multiple events that have the end after the current day. So you would do something like you have a stack that is 10, 100, 2. You have a stack that does this, or queue? Heap? Because maybe in theory you could have 2, 2. Can't really be a stack at that point. So you need to pop this 2. So like maybe 2. Yeah. Maybe use a heap to keep track of the smallest end day, and you push onto the stack. Push onto the stack the end days of events as long as the start date, as long as this day falls in the event. And then once you can't do that, like 2 can't fall into this event, or day 2 can't fall in it, then you take off the heap smallest end date. Yeah, smallest end date. Alright. I'm gonna go with It's going to be double sorting. I think there should be a way that's faster than this. Or it's going to sort twice, I guess. Alright, let's just see how this goes. Events.sort. And then let's say day is 1, answer is 0. And I'll have a heap to keep track of the smallest end date. Heap, say end heap. Track smallest end date. Yeah. Tracks smallest end date of valid events for current day. Okay. I'll say I'll have an index. So while the index is less than n, where n is the length of events, if the, I'll say start and end of this current event is event set index. If day is less than, so I'll do the simple case here. If day is less than I'll assume that the heap is empty for now. Day is less than events or the start. And then it's fine to assign, I guess, what happens if there's a heap currently? So what happens if there's a heap currently? Okay, let's say this is currently for no heap. Then I want to assign this event to this day. So answer is going to increase by 1. I'm just going to move on after this index. Day is going to equal start plus 1. So like I'm thinking I'm at day 0, I'm looking at 1, 2. So it has to skip over days to get to 1, 2. So it's going to automatically assign the 1, 2 to day 1. And I move day to day 2. And then index moves on. Okay. Else this is going to be something that overlaps. So I think I want to do while index less than n and say index less than n and end date, the end date day is less than or equal to the end day. Less than or equal to, just equal to, or just less than. Less than, no, less than or equal to end day of this event. Then I should add the end heap dot or heap push onto the end heap end day. So this event is going to have a valid ending that is possible to be used. So day 2, I push onto the end heap 10, 102, as long as no, I don't think this is correct. As long as the current day is valid, so the current day is greater than or equal to the start. Yeah, okay. 2 is valid for any of these. It's not the end day that I'm looking at. It's the start day is valid for all these events. So if the start day is valid for all these events, then I'm really caring only about the end day of those events. And they would be pushed. 2 is not valid for this. Okay. And then I need to increment the heat. Well, I guess I this should probably be events that index the start, which is going to be 0. This is events that index 1 and then index plus equal. Yeah, this is not gonna. I think maybe I shouldn't have this. This index is going to change, and I'm going to use the code based on the changes. Alright, well, let's not worry too much about that. So I have 10, 100, 2 on the heap. So if there's nothing that is assignable, then assign something new, the next thing on the heap. Yeah. I guess this should be this, and it's empty. Ugh. Okay. This should be end heap, not end heap. Keep on going down. There has to be, yeah. There has to be, and after this I have to take out the earliest event, or the event with the earliest end date. So end heap or heap pop and end heap first of them, and then the day is incremented by 1. Yeah. So I go 10, 100, 2 on the heap. That's the only days where, that's the only events where day 2 is valid. Then I take 2 off the heap, so now the heap has 10 and 100, now the day is 3. And then I do this loop again. The index here is 3. The index here is 3, but maybe the index, what if the index here was, let's say 4, right? If it's 4, ooh, what happens if it's 4? So the day is before the current start date of the index. But if there is a heap that has 10 and 100 already, then for each okay, let's just say it's more extreme, right? Let's say it's like 8, 9. I think what happens is for each event, for each day between the current day and the current start date of the event at index. So I assign day 2 to this event, and like I can assign day 3 and 4 to these 2 events, which is in the gap between this. So the gap between this can accommodate the number of events in the heap that have yet to be assigned. Yeah, the difference between the current day and the start day, I can remove that number of elements from the heap, or I can pop that number of elements from the heaps, the lowest one first. Okay, so I can say, before I do this part, is it always true that I want to, the current day is now 3. Current day is now 3. What if there was like 100 elements in the heap? So there was like 100 1 to 100 events. Then I wouldn't really assign, I'm not guaranteed to assign this thing 8, 9 to day 3 at all, or day 8 at all really, because maybe I should be just doing this outer while loop first. Yeah, maybe I should start by checking if there's stuff in the heap to assign to this day. Not really, right? I want to be able to skip days. I don't want to necessarily go through all the days. So if possible, I want to skip. If day is less than start and there's no heap. Yeah, it has to be and no heap. No heap being not the end heap, which treats it as pretty much, yeah, that's true only if it's totally empty. The day is start and not the end heap. Okay. And then else, yeah, else do this stuff. So for instance, look at the current day, add this event to the heap if this is still a valid day, so don't necessarily increment anything. And then take off top, move to the next day. And you can't do any jumps as long as there's, can't do any jumps because all the stuff in the heap is valid. Yeah, I wonder. So you're at day 3, you see the current event starts at day 8, then you basically don't add anything onto the heap. You pop the 10 off the heap and say that that's used for day 3. Move on to day 4. At day 4 is still after this, is still not valid for the current event 9. And then you pop the 100 and assign to day 4. Do it again. Maybe there's I think I'm going to do one hack and that's to try to prevent having to do this check each time. So I think I can possibly do kind of a big event. A finale event that is a bookend to this event's add on to the events list a finale event. And I know that once it does it, it's gonna give me the days. So I think here something like events.append infinity, something like that. Oh, answer should increment by 1 here. Okay, so so it starts out at day 1, but let's assume it starts out at day 0. Then it's going to do this first one and assign the 1 to day 1. And then it does the second loop. So day 2. Day 2 is valid for all 3 events, 110, 100, 22. It's going to add all those to the heap. It's going to have index be at 8, 9. It's going to pop the 2 off the heap. It's going to say it's day 3. And that day 3, the heap's not empty, and the start date is not valid for this day. So it's going to not push anything. It's going to pop the 10, assign it to day 3. On to day 4, again, heap's not empty. 4 is still not valid for 8, 9. Pops the 4. Goes on to day 5. Day 5, the heap's empty. Day 5, 8, 9 is after 5. So it's going to just skip to day 8. Or skip to say that this is assigned to day 8, now days 9. Then move on to the next. Okay, that looks good. And here I can think, how can I break this using this extra appended stuff? While think I can say here, I can always index, say if the events at index starts with infinity or does not start with infinity. If I see infinity, then I know that I can stop. And I know that I can always compare the day to be, the day is never going to be bigger than infinity, so it's never going to stop. So I think this is, yeah, it's never going to increment past that. Yeah. And I can say return the answer here. I'm really hoping, oh yeah, so one final thing is if it reaches the end and there's still a heap, well, how would it reach the end when there's still a heap? Yeah, it reaches the end and there's still a heap. Then reaches the end and there's still a heap. Then what? Then the number of unique days. So let's say it's 1, 2, 1, 10, 1, 100, 2, 2, and then infinity, infinity. So assign systo day 1. I'll assign this to day 2. I'll assign this to day 2, and at that point it's at day infinity, or it's at the start date's infinity here. Today is day 3. Today is day 3. Okay, so I think maybe I need one final while loop. So there's no, at this point when it stops, the index is at something with infinity, infinity, so there's no more events that can be kind of pushed onto the heap. And it's strictly a matter of assigning valid days to stuff on the heap. So I think it's going to be something like while end heap is this, and the current day is less than, or let's see, yeah, less than or equal to this, the smallest end day. No, I think it should be end heap. If the current day is less than or equal to, the smallest day here, then increment the day, increment the answer, and pop the end heap. So you assign that day to that smallest end date. So like 3 would be assigned to 10. But what if it was 3 is trying to assign to 2? Else, if 3 is assigned to, if it's, actually I think it's, well, end heap, so while end heap and smallest smallest ending is before the current day, less than the current day, then just pop that. So if you have a bunch of 2s, then none of those are valid for this current day. So and then if there is still an heap, I think here I'll probably do something that hacks the end heap as well. Can I? No. Maybe I can, maybe I can't. Well, end heap start date is before the current day. For a while it's not valid. Take it off. If there is something valid, then remove it. Move on to the next day. And then keep on doing that loop. I guess. Okay. I think this might work. It's a little to say at least this looks bad. While the same conditional followed by an if statement with something similar conditional, there has to be some better way of writing that, structuring that logic. Okay, so what do we have here? My thing was 20, the actual thing is 18. Okay, so let's go and print out the events here. Interesting. How could it possibly have done multiple things in the same day? Huh. If the day is less than the day I'm earliest. So 4, 6. So it should be signing 4, 6. So day 1, I look at 4, 6. 4 is after it, so it should be assigning day 4 to basically this. Moving on to day 5. Day 5, it should say that this is added to the heap, and then this is not added to the heap because 5 is before 6. So then it should be popping this thing from the heap and saying that that's assigned to day 5. And then moving on to day 6. Day 6, it should be saying that six is before the start. It's not true. Yeah, so it should be signing the 6 of this one. Day 6 is 4. 6 is less than 6 is false. So it should be actually doing this. Pushes the 9 and the 10 onto the heap. Although it should be really able to assign if the day is less than start and end heap is not there. I guess maybe. I wonder if I even need to check whether or not the day is less than start. What if the day is equal to the start? So what if I had a bunch of 1-1s? There's nothing on the heap. The day is less than or equal to the start. There's no heap. Then nothing prior to this is valid. Yeah, I guess what happens in my code if it's a bunch of 1-1s? Like there's 10 events that all occur on the first day. So the day is day 1. This is false. So it pushes. Okay, yeah. Pushes a bunch of 1s onto the heap. It pops a 1 off the heap. And then the day moves to day 2. And let's say day 2 tries. Okay. Tries to push the valid stuff, but needs to remove the invalid stuff off the heap first. So push valid events. Valid events for day onto heap. I think I need to remove invalid events for day off heap. So while end heap and the earliest ending event is before this current day, and heap.pop. Yeah. Moves invalid, pushes valid. It'll push something. Will always push something valid. While day. What if it never finds something valid? This is probably gonna crash. Yes, this might not find anything valid, right? So for instance, let's say all events are on the first day. So first time it iterates this, it adds all the events to the end day, to the end heap. And that's just a bunch of 1s. Pops a 1. Says there's 1 day, and now it's day 2. Or one day answer. Now it's day 2. Day 2, end heap is not empty. It moves all the 1s from the end heap. And now there's the day is day 2. 2 is not bigger than infinity. So it doesn't do this at all. And now it tries to pop off the end heap where there's nothing on the end heap. If not end heap, then I think I need a break here. In that case, I even need to have this check. I don't know if I need to have this check. Okay, let me see if this just fixes the issue. Okay. Okay, now to, this is really, there has to be some consistent logic that makes this a lot better looking. So I break because there's no valid event for the day, pretty much. If there's no valid event for the day, the end heap is going to be empty at that point. But if there is a valid event, then the end heap will, I can pop the smallest. Then at some point I get to the index being infinity. Get to the index being infinity. At which point I can try to assign everything off the heap. So I think if it's not, I don't even need to break here. I think this is just the valid answer. If there's no assignable things, there's no event that is assignable for the day, then if there's no event that's assignable for the day, I wonder if I even need this if statement. The day is less than start. And there's no end. I wonder if I can just say while there's an end heap. So what if I just had this at the start of the loop without this portion? So I'm at a certain day. That certain day I should be able to remove everything that's invalid for that day every single time to start off the day. So I think, okay. So I know the current logic works. I just need to, or I just want to see if I can figure out a better way to structure this that's more aesthetically pleasing. So I know that this is always good. I should always be able to remove invalid stuff for today. I don't know why I retyped that instead of just copy and paste it. And then yeah, this actually, if I get to the last event, infinity, the day is less than infinity, the end heap is empty, then it's actually going to count that as a valid thing. Yeah, that doesn't make sense. Maybe I just do a while true loop here. Wonder. Oh, that's really not how I should be commenting stuff. So while true, end heap day is less than the start. Take off the thing from the heap, and then push all the valid days for today onto the heap. While day is greater than the first day, then heap push the end of this event. And I can say index +1, and then I can try assign. And if I can't assign, then I should be able to break. So if there's nothing available for today, otherwise I assign today's to the earliest thing that's available. Is this right? What happens if there's a jump? What happens if there's a jump? If not end heap. Yeah, that's not right. There's no way this is correct. So if the day is day, if there's, let's say there's an event that's at day 1 only, like 1-1, and an event at day 3 only. So it does the one event, pops out in the heap, moves on to day 2. Yeah, so it's not doing that logic right. So it's at day 2. There's nothing on the heap to move. That's invalid. Day 2 is not after the start of this event, which starts at day 3. So I think maybe, if not end heap, then I need to not return immediately. I think maybe I can say if there's not end heap, an index say it's an empty end heap, then if the next valid day on the heap is infinity, or if the next valid day is infinity, then yeah, I'm done. Otherwise, just push the earliest date on the heap. Push the earliest event onto the heap. I'm doing some pretty bad habits here. I'm kind of mixing the code that was correct with the code that's experimental and hoping the experimental one turns out fine, rather than doing some better modifications. Heap push events index 0. No. what's going to happen here. Yeah. So if there's no heap, I don't even need to go to the heap process here. I can just say arbitrarily that I'm assigning this index to this day. So index plus equals 1, day, day is equal to the next day after this index, events index, start day. And no, sorry, day is equal to this, not plus equals. Answer plus equals 1. So I just avoid putting it on the heap at all. And then I break when I see the end heap is, if the end heap is empty and the current event is infinity. I think maybe this might work. It's just like dummy code down here. Okay. Wow, that was just like such a coin flip that I would edit my code like that and go for what I think might be workable, not necessarily. I didn't even check if other code worked for the general cases. Okay. It's like me, like, I don't know. It's just, I know I'm kind of losing my abilities at the current time because I'm doing some pretty bad coding habits and not really being able to think through things. Okay. So this is removing the invalid events for the day. This is adding all valid events for day onto heap. And then this is assigning day to event stuff. So if there's nothing, no possible assignment if the heap is empty and you're at the last event, the dummy event. No possible assignment if at dummy event, the dummy event being at infinity, end of time. Otherwise, skip to next event. So if there's nothing event that's valid for the day, let's say it's day 100, I could put there was a bunch of events that happened before today, but the next event is this day 1000, then skip to that day event. Don't even bother putting on the heap because you're going to take it off the heap immediately. Otherwise, take earliest ending valid event from heap. Increment the day. Okay, yeah, this logic is good. This logic was also okay, but it just was well, it was logically correct, but less efficient. Sort event is a better way of ordering this stuff. So my index is 0, n is the length of the events, day is 1, the answer is 0, and the end heap is going to be that. Of end dates, heap of end dates of valid events for current day. Because I say valid events would be equivalent. Alright, I think this is as logically sound as I can make it. Alright, so summary, this is going to be summary. We're going to use is this a greedy approach? I guess I wouldn't say this is a greedy approach actually. Uses in general use a heap to keep track. Man, I should probably stop not capitalizing stuff. It makes it worse looking. In general, use a heap to keep track of events that are valid. Keep track of end dates of events that are valid, and takes away the earliest ending event, since that has the most limited range for future assignment. Like if you have something that ends in only today, like 1-1, versus something that ends 10 days from now, 1-10, 9 days from now, you want to assign the one that ends earliest to today, so that I guess that's always going to be, I guess that's somewhat greedy. Yeah, I mean the logic there should hopefully be straightforward. There's no better assignment than the earliest ending valid day. So steps would be like sort the array. Secondly, remove invalid. I guess the pre stuff would be create variables, empty heap, remove invalid. Day equals 1. Sort the array to remove invalid, and then in a loop, in main loop, which will in theory go through all days and indices. But here I just have a while true loop, since I know that there's going to be some breakpoint to it. Remove invalid end dates, invalid events from heap. Basically, if the end date is earlier than today's day, and that's, for example, if you have a bunch of events that have the bunch that has end dates of 1, the heap will be 111, and on day 2, heap will have like 11, which are both invalid. So they need to be removed. So if on day 1 events have, so if on day 1, if you ever end up in a day where there was a bunch of stuff added to the heap prior that on a prior day that were valid for those days, but now is invalid, then you need to remove those. So that's first one, remove invalid events. Add all valid events onto heap. So that was this thing right here. While the day is greater than or equal to the start day of events at index. Add all end days of valid events on heap. Look at that. Add the end date, increment the index to the next index, and then this is the main thing. After, if nothing on heap, either A, no more valid events, break, or B, day is too early for next valid event, then skip to that event. Basically, skip days to start date and go to next index. Start date plus 1, because then you already know that you're assigning it to that date. Otherwise, take earliest ending day, earliest ending date off heap, and move to next day, not necessarily next index. And then slight optimization, adding dummy event. Add dummy event to events array to know to break loop when dummy is seen. This removes the need to check for indexes less than n for a bunch of those conditionals. So for instance, in theory, you would need to check index less than n and this if you didn't have the dummy event. I guess that's not that big a deal. I guess that's one less check. I guess the only thing then you'd have to say here, you'd rather say here if the index is equal to n. Yes, yeah, I guess it's only one optimization there. If index less than n and day is greater than equal to index event at index 0, whatever. Alright, anyways, time complexity, this is going to be O of n log n to sort the overall events array, and O of n log k for maintaining heap during the main loop, where k is the size of the heap, which could be at most n, but is expected to be the average size of the average number of valid events for any given day, which is considerably smaller. Like the heap is just number of is the sorted the heap maintains the sorted, I guess it's not even sorted, maintains some information about this earliest ending valid day. And the earliest ending valid day, I mean, hopefully it's not going to be all events in the thing. But when you insert onto the heap, it's a log n operation or log k operation where k is the size of the heap. Okay, and then space complexity, this is going to be O of n, no. What is the space operation here? This is going to be O of k, where k is the, I guess in this case it's the maximum size of the heap, which in theory could be O of n, where like you have pretty much everything valid.